Hello everyone, welcome to a new video. Today's GFG problem of the day is fractional knapsack. So let's see the problem statement given. Given weights and values of n items, we need to put these items in a knapsack of capacity W to get the maximum total value in the knapsack. So we are given with an array of values and an array of weights of a particular product, let's say, and we have to fill the knapsack, or let's say we have to fill a bag with some products whose weights are given, right? So the bag has some capacity. In the first example, the capacity of the bag or the knapsack is 50 and the weights are 10 for the first product, 20 for the second and 30 for the third. So we have to fill the bag which has a capacity of 50, and we have to fill those product in such a way that we get a maximum total value. So this is basically a very common problem and yet interesting. So let's take the first example and decide how to approach this problem. So this is our given example. There are n number of products, let's say, and the weight of each product is given in the weight array, and the value of particular products is also given in a value array. And we have to fill a knapsack whose capacity is 50. This is also given. So let's say this is our knapsack whose capacity is 50. So to understand this, let's say this bag can contain, or the knapsack can contain 50 kg of weight, and we have the product of 10 kg, 20 kg and 30 kg with rupees 60, 100 and 120 respectively. Just to understand the problem more easily, we are giving some units to the values. So as we have to return the maximum value, we need to find out the maximum profit. Only those product we will add who returns the maximum profit to us. So how we will calculate the maximum profit for each of the given items? So if we consider the first product, the weight of the first product is 10 and the price is 60, the value is 60. So for 1 kg the price will be 60 by 10. So we can say the price of 1 kg of the first product is 6 rupees, we can say that. And if we consider the second product, the weight of the second product given is 20 and the value is 100. So for 1 unit, what will be the price? 100 by 20, that is equals to 5. And lastly, we can take the last product that has a weight of 30 and the value given is 120. So for 1 unit, the price will be 120 by 30, that is 4. So we can see by this calculation that the first product is giving the highest profit to us. And accordingly, the second product is giving the second highest profit. And the third product is giving us the least profit or the least value out of all the product. So as the question asks, we have to return the maximum value. So which product you will put into our knapsack at first? We will simply put the product who has a greater profit or which returns a greater value. So accordingly, we will put the first product in our knapsack. So if we put the first product that is of 10 kg, so we have covered 10 kg out of 50 kg of knapsack. So we are left with 40 kg of capacity. The knapsack can contain 40 kg more products. These units I am taking just for explanation. These are basically the weight given in this weight array, and I hope that point is clear. So now we have to fill 40 kg of knapsack, and the second product is of 20 kg. So if we can totally put 20 kg of product in our knapsack, so we will be left with 20 kg of knapsack capacity. Means we can put 20 kg of products more into our bag. But if we see the last product, the weight is 30 and we are left with 20 kg of space capacity in our bag. So it is clear that we can't put the whole 30 kg into our knapsack, right? Because the capacity is 20 and the weight of the product is 30. So it is not possible. So we will put only 20 kg of this product. So if we put 20 kg of the third product in our knapsack is filled, totally filled. 20 plus 20 plus 10, that is 50 kg. But the thing is, we have to calculate the value of 20 kg of the same product. The value of 30 kg of this product was 120. And we have calculated the value for 1 unit also. So the value for 20 unit of same product will be 4 into 20. That is so simple. So the value will be 80. So for the last product, the value was 80. For the second product, we have added the whole product whose value was 100. It was given already. So the value was 100. and the first product we have added of 10 kg, the value was 60. So if we add up all the values, what we will get? It is 0, 0 and 240. So we got a value of 240 and this is our final result. So basically in this problem, we have to find the profit of each of the product given, and the one who has the maximum profit will be entered into the knapsack or our bag first, and accordingly we will keep on putting all the items into our bag until our knapsack gets filled, and each item we have put into our knapsack we will calculate their corresponding values, and at last we will return the maximum profit. In this particular problem, the items are already sorted in a descending order of their profit. See, the first item we have took has a weight of 10 and we have calculated the profit as 6, which was the highest. So it was already in a descending order. That's why there was no need of sorting. But for other cases, we definitely need to sort all the given items based on the profit. So for that, we will use comparator. And if you are new to the concept of comparator, I have made a dedicated video on comparator. You can check it out. But this was all about the problem. Now the question arises, what if put the items into our knapsack based on the profits we have calculated? So let's see a small example. If we add the last item at the first, which has the highest weight, that is 30. So in our 50 kg of knapsack, we are adding 30 kg of the product whose value is 120. So the value will be 120 and we are left with 20 kg of knapsack capacity. The next item is 20. If we add this, so we are left with 0 capacity of the bag, and we have added the value of 100. Right. So the total value will be 220, which is not the maximum. The maximum is 240 and we have to return the maximum. That is why we have to sort the items based on the profit they return. And accordingly, we will put every item into our bag until it gets totally filled. So I hope I was very clear with the explanation of this problem. Now let's get into the code quickly. Before starting with the code, let's notice this point that unlike 01 knapsack, you are allowed to break the item here. This line basically means we can take a part of a given item and add it into our knapsack. So we have did it right. For the last item, we took a part of last item. That is, we added only 20 kg of the last product out of 30 kg. So we took a part, and for that part, the value we have calculated, that was 80. So that is what it is saying. Unlike 01 knapsack, in 01 knapsack, breaking of item is not allowed. In that problem, either you can take a product as a whole, that means you have to take 10 as a whole, take 30 as a whole. You can't break these items like we did in our fractional knapsack. So in 01 knapsack, 1 represent that you took the product, and 0 means you have not considered that product. So I hope there is no confusion in that point. Now let's get into the code. In our code, we have started with sorting our given array based on some custom logics. And what was our logic? We have discussed that we have to sort the items in descending order of their profit, of their return profit. So see the comparator here. We are basically comparing two items, and in a variable p1 we are storing the profit of first item, that is value divided by weight. That is what we have did it here, right? The value was 60 for the first product and the weight was 10 and the profit it was giving is 6. So that is how we have calculated p1, profit 1 and profit 2. Then we have checked which profit is greater, and accordingly we have returned some values. So how do we implement comparator interface? How do we create our own custom logics to sort array of or any objects in Java is explained in detail in a video. So please do check it out if you are not aware of this topic. And then you can easily create your own custom logics to compare objects in Java. So basically here we have sorted our arrays based on the profit they will return in descending order. Then we took two variables. Our result will calculate the total value, and which we have to return at last. And added weight will calculate the weight we have added in our knapsack till now. So we started our loop from the first index of the array, that is for the first element who has a maximum profit, till the last element of the array, and then we check the added weight which is already present in our knapsack and the current weight of a item. So for the first case, the weight was 10. The weight of the first item was 10 and there was no item in our knapsack at first. So the added weight value is 0. So 0 will be added with 10, which is less than equals to our given capacity of knapsack, that was 50. So if this condition becomes true, we will simply add the current weight into our knapsack, and we will also add the corresponding value of that item in our result variable. This is what we have done in our example. See, the first item was 10 based on the given profit, highest profit. So 10 was added and the corresponding value was added, that is 60. In the second case, 20 was added in our knapsack and the corresponding value was 100. So 100 was added in our result. So this is what we have to do till we totally fill our bag or the knapsack. In the else part, we have to calculate the remaining capacity of our knapsack. We have did it, right? The total weight for two items was 20 plus 10, that is 30. And the capacity of knapsack was 50. So we can add only 20 kg of item in the knapsack. And accordingly, we have calculated the value of 20 kg of the third product and we have added in our result, that was 80. The 20 kg of the third product returns a value of 80, thus we have added it. So similarly, we will calculate the remaining weight which we can add in our knapsack, and then we will simply update our result variable. The value of the product will be multiplied by the remaining capacity of the knapsack divided by the weight of that item. The same thing we have done. If you check, we have divided the current value of the product with the weight of the product and we get 4. And with this value, we have multiplied the remaining capacity of our knapsack, which we can add in our knapsack. So we can add 20 kg more into our knapsack and the value of 20 kg of the same product will be 80. So we will add 80 in our result. That is what we have done. By this time, we have filled our knapsack totally. Thus, we will break from the loop and return our final result. So I hope you have found this solution pretty simple. Now let's compile and run our problem. So the program is compiling fine. Let's submit our problem. And yes, the code has successfully passed all the given test cases. So I hope by this video you have got to learn something new about a knapsack problem. And there was a brief introduction of 01 knapsack also. And even if you have faced this problem before, I hope it was a good recap of the topic. And if it was, please like, share, and subscribe my channel. And we will meet with a new problem very soon. Till then, happy coding.